In the next 5 to 10 minutes, I will be showing you the problems along with the concepts from which questions are confirmed in your NEET 2026 examination. I would say 30 to 35 marks you lock in this particular session. So let's dive into this particular session. First one, you have work energy theorem. Extremely important. Let's understand. We say according to the work energy theorem, it says work done by all the forces is equal to change in kinetic energy. Like this, work done is equal to change in kinetic energy. That means final kinetic energy minus initial kinetic energy. So you can write it like this, 1 by 2m v final square minus v initial square. This is the way you can write work energy theorem. Now let's take a look. First question was asked in JEE 2026 examination. There is an object, it is having the velocity 2x square. And after some time, x is equal to 5 meters, the object is here. Could you please tell me, and it is saying, how much is the work done by the object from this point to this point? You will be applying work energy theorem. So final kinetic energy minus kinetic initial. 1 by 2m v final square minus v initial square. Now 1 by 2m, mass of the object is given as this. Now v final square. Final velocity is here. So final velocity is when x is equal to 5. Put x is equal to 5 over here, you'll be getting v as final as 50. Put x is equal to 0 over here, you will be getting initial velocity as 0. So v final is 50 square minus 0 square. Work done will be, I would say, 1250 joules. Next concept. Next concept is basically, my dear NEET aspirants, power. So this is very important. We say power is F dot V, force dot product of force and velocity, or FV cos theta. This is from this particular portion. Directly question was asked in NEET 2023 examination. There is an object, okay? It is having the velocity, this one. This is the velocity given in the object. And this is the force acting on the object. You are supposed to find power. Power will be simply F dot V, dot product of this and this. How do you do the dot product? Coefficient of this multiplied by coefficient of this, 10 into 5. Coefficient of this multiplied by coefficient of this, 10 into minus 3, 20 into 6. And then you can get the power over here. I would say it will be 140. So done and dusted this one also. Then, my dear NEET aspirants, in case of collisions, we study loss in kinetic energy. Now, when it comes to the elastic collision, that collision where kinetic energy initial is equal to final, here kinetic energy loss will be 0. When the inelastic collision takes place between the two objects, we say loss in the kinetic energy is 1 by 2 m1 m2 upon m1 plus m2 into u relative square. U relative means u1 minus u2. u1 minus u2 means initial velocity of object is having the velocity u1 initially, second object is having the velocity u2. I'll be showing you the question also, 1 minus e square. Now for perfectly inelastic collision, this is the formula, 1 by 2 m1 m2 upon m1 plus m2 into u relative square. Let me show you the question. See, this is the question. There is an object, it is moving with a velocity, this is what we call as u1, and this is moving with a velocity, this is what we call as u2. Now here in the question it says it is performing the perfectly inelastic collision. If it performs perfectly inelastic collision, then what is the loss after they collide? What will be the loss in kinetic energy? That is 1 by 2 m1 m2 upon m1 plus m2 into u relative square. U relative means this u1 minus u2 whole square. Now 1 by 2 m, mass of first is given as 20, mass of second is given as 80, divided by 20 plus 80 into u1 minus u2. u1 is 4 minus 2 whole square, so it came out to be 32 joules. I hope this question is also clear. Then, my dear NEET aspirants, one more important concept over here that I would want you guys to remember. Let's suppose you have an object over here, you release it, and this object falls down on the surface. Let's suppose it falls edge down. Then it will basically collide, and it will basically come back. Okay, it will be this is what we call, after the collision, it will be raised to this height. Again it falls down. Again it raises up to this height. Again it falls down. It is like this. And if you release an object, it falls down and raises up to height. Again it falls down, raises up to this height. Again it falls, raises up to this height. Okay, so the question will be, how much will be the total distance covered till the object comes to rest? Till the object comes to rest. So this will be the total distance or total height covered till the object comes to rest. H into 1 plus e square upon 1 minus e square. E is basically the coefficient of restitution. It will be given in the question itself. And then if somebody says, if you release this object, in how much time this object will come to rest? So this is the time taken by the object to come to rest, under root of 2h by g into 1 plus e upon 1 minus e. This is the total distance covered before it comes to rest. This is the total time taken before it comes to rest. Conservation of angular momentum. Conservation of angular momentum, my dear NEET aspirants, say if net torque on an object is zero, listen to me very carefully. If net torque is zero, it means angular momentum is conserved. It means initial angular momentum is equal to final angular momentum directly. Conservation of angular momentum means initial angular momentum is equal to final angular momentum. Angular momentum is equal to I into omega. Here, final angular momentum will be I into omega, I dash into omega dash. I means moment of inertia, omega is angular velocity. Then, my dear NEET aspirants, there was a question asked in JEE 2024. Now, here, this is a disk which is having the mass m, radius r. It is rotating with angular velocity omega. Its moment of inertia is I. Now, if you place one more disk on the previous disk, which is having the mass m by 2, so its moment of inertia will be I divided by 2. Angular velocity final is omega dash. You have to tell me what will be the final angular velocity. With what angular velocity it will finally rotate. Now see, you say angular momentum initial is equal to final. So I into omega is equal to I dash into omega dash. What is the initial moment of inertia? I. Initial angular velocity omega. Finally, moment of inertia is I by 2 plus I. So that is I by 2 plus I, 3I by 2. So final angular moment of inertia is 3I by 2. Final angular velocity is omega dash. So from here, you can say this and this will cancel. You can get the value of omega dash. Okay. Then gravitational potential energy. Listen to me very carefully, my dear NEET aspirants. Gravitational potential energy of Earth mass system. Let's suppose this is Earth over here. Its mass is m, radius is r. Now, there is an object of small m present on the surface. Now, boys and girls, if this is present on the surface, what is the potential energy between Earth and this mass? Minus g, mass of Earth, and this mass divided by r. If you take this mass to the height h, what will be the potential energy final? Minus g m divided by r plus h. Then you will be considering this r plus h. Now, if you do u final minus u initial, this will be the change in potential energy. Okay, so what is the change in potential energy if you take the object from this height h, surface to the height h? Now, if you simplify this, it will come out to be like this: mgh upon 1 plus h by r. This question was asked in NEET 2017, NEET 2019, NEET 2022. Extremely important, I would say, my dear NEET aspirants. Then, if you check the question over here, an object is basically raised from the surface to height h is equal to 2r. It says what will be the change in potential energy. Change in potential energy is mgh upon 1 plus h by r. So mg, instead of h, you will write 2r upon 1 plus, instead of h, you can write 2r divided by r. Then solve this, it will come out to be 2 by 3 mgr. Then escape velocity, my dear NEET aspirants. Let's suppose this is Earth over here. On the surface of Earth, you have placed an object. You are launching it with a velocity. When you launch this with a velocity, it goes, and it goes out of the gravitational field of Earth. It does not come back to the Earth. So this velocity with which it moves out of the gravitational field of Earth, that is what we call the escape velocity. The minimum velocity with which you can escape from the gravitational field of Earth, that is the escape velocity. And its value is under root of 2 gm by r. So escape velocity is 11.2 meter per second. And escape velocity in terms of density is, this is r under root of 8 by 3 g, universal gravitational constant, rho, and this would be pi. This is in terms of density. In terms of density, escape velocity is directly proportional to r. So graph will be the straight line. And in terms of mass, escape velocity is inversely proportional to radius, r. So graph will be rectangular hyperbola. Okay, now there is a question on this escape velocity. This is solved over here. I would want you guys to check this out and solve this from your end. Okay, so that's all for today. Make sure you smash the like button. All of these questions are very, very important, from which you can expect the questions. Take care and bye-bye. Thank you so much.